Okay, we're here with period 1, going over some review questions before our test tomorrow. All right, it is going to be a little bit shorter class, so what I've done is I've shortened what I normally would have given you for a test day. I've shortened it by a few questions, so you should have enough time tomorrow to do the entire test. Number 1, let's look at number 1. Find all of the zeros noting multiplicities. So the first thing when I hear that, find all the zeros, is I want to find what makes all of my factors become 0. All right, now it's already factored for you, so hopefully this can go much quicker. You want to set each of them equal to 0. So what makes x plus 3 equal to 0? Negative 3. What about, this one's a little tougher. If you need to do a little algebra, move the 1 over. So if it's a negative 1 here, when I move it over, it becomes positive 1. And if you divide both sides by this 2, you get x equals 1/2. And finally, what makes this one 0? Actually, negative 1. You're fine, it's okay. All right, and then ultimately you would need to write about the multiplicities. This x plus 3 said squared, so this root is called a double root. So that's a double root here.
What's a double root? Can I have a definition, please?
Yes, double root means that it comes from a factor that has been squared. That's algebraically. Graphically, do you remember graphically if it was at negative 3, a double root, what's this, 2, 3, hold on, doing some math here. So it would look like this, where it would touch and come back. You see how it doesn't cross? That means it's a double root. All right, that's graphically. All right, what about this 1/2? What kind of root is this? Single root, right? It comes from 2x minus 1, not raised to any power except for 1. So this is a single root, single. And then what about negative 1? So triple root. So graphically, that would look, let's see.
So it's a double root and triple root if it's like to the second power or third power?
So that would be, let's see if I can do this. Oh, I put it in the wrong spot. It's okay. But it'd be like you go and it would look a little squiggly. It kind of like when it crosses, it does a little squiggle before it goes up. Because if you remember x cubed, looks like this. X cubed looks like that. So it kind of like flattens out a little bit. That's how you know it's cubed. Sorry, someone was asking a question. Lily, were you asking a question? No? Heidi. Yes, when it's to the first power, it's single. Pablo.
Why isn't it going the other way then? From up to like a double root? Because if they're...
Are you talking about which graph? I did 2 graphs. This graph?
Yeah.
So what makes it triple?
No,
Bless you.
what makes it triple, but like why doesn't this one a double?
Are you talking about like both of these are going up?
Yeah.
That's because it's squared and cubed is 5, plus this one makes 6. So if you remember when it's an even power, they have to go the same direction, either up or down. And do you notice, is there a negative out front? No, so they'll both go up. That's not going to be on the test, but it is good to know. That's called end behavior. End behavior. It was going to be on the test, but I cut that problem.
Thank you.
Well, not because of anything besides time, so you can thank whoever scheduled the assembly. Guess we'll find out tomorrow together. We're wasting time. Number 5. Thank you, Giuseppe. Number 5. This is in the same idea of what we just did, but now this is a great question to follow up with, Giuseppe, because this is asking about doing the same thing, but with graphing it. Yeah. No, it's the combination of the roots and what type of root it is. So like I think it was x equals negative 3 was double, x equals 1/2 is single, x equals negative 1 is triple. That, all of that, yes. Yep, so I need the zeros or roots and what kind they are. That's the multiplicity part. That will definitely be on the test tomorrow. Okay, number 5. So I notice let me use a different color here. I notice a root here. What do you think that root is? Actually, it's single, right? It just crosses normally, nothing crazy happening. So that's going to be 1, 0, and I would write single. So that's that's exactly what I write on the key. I write it when it's graphing, I write it as coordinates. Bless you. You could write x equals 1, Dino, I will accept it. But when I see graphs, I think ordered pairs. What about this other one?
3, 0 is simple, no?
So do you see, Pablo, this is, let me erase it now that I drew on it. Do you see how it kind of does like a little squiggle before it kind of goes up? That's telling me it's triple. It's not, so okay, don't think that because this is 3, it's triple. It's triple because it doesn't just cross normally. When it gets there, it kind of does a little bit and then goes up. That's how you know it's triple. Because remember, the graph of x cubed has that little extra stuff at the origin. Double is when it touches, like this one here. Do you see how it touches -2 and then comes back the same side? That's how you, excuse me, that's how it's double. You can think of parabola. Let's go Pablo, Lily.
So it has to be in the x line?
Yeah, I only care about the x-intercepts. That's what it's asking about, the zeros or the x-intercepts.
So there could have been a double by positive. If it was
By positive 3?
positive.
Positive 2. Well, it would have to cross at 2.
Yeah, I'm saying like it could have been a double one. If it was by the you know.
I don't know. This is a double root. It has to hit the x-axis to be a root, to be a 0. If it doesn't hit, it's not a 0. I think we go Lily first question, and then 4.
So it's single if it passes straight, like
Straight through, normally single.
normally.
Yeah. So I think Diana said let's just do number 4. Okay, fine. So we already said -2, 0 is going to be a double root because it touches -2 and then comes back in the same direction.
So when it's in the same direction, it's a double root? Like,
Yes.
the same direction?
Well, it's not really 2 in the same direction, right? Because ultimately there's no arrow here. We're still going. Just it doesn't cross the axis. It touches, but it doesn't cross. Okay? And the other one is +2, 0. And that looks like it's just crossing normally, so single. I'm expecting you guys to ace this part. For algebraically and for graphically. Now, be careful. We only asked about number 1, which was no factoring.
Yeah, number 2 is hard.
Yeah, the other ones have some factoring. 7. Okay, long division is definitely on the test. Go
We
away.
have a choice as to whether we want to do long division or synthetic.
Nope. I make you do both. Like I say,
You have to put in a placeholder
for number 7, yes.
for the other side.
Yeah, so let's do x plus 1 out here. 3x to the 4th power plus 0x cubed. Right, that'll be something that could happen, wink wink, tomorrow.
Oh, no.
Okay, I don't know why we're... What could happen, Pablo? What did I just say? I said wink wink.
You have to have a placeholder, like you're gonna end up with, yeah, like, you go from 4 to 2, you have to go 4 to 2. But it's on your house.
You got to go in order. Just remember your favorite animal, the ox.
I don't get it, why?
I guess.
0x.
Yep. Thanks. All right, that's why they pay me the big bucks. All right. Really? Mean-spirited. I need to figure out what am I going to multiply x by to get 3x to the 4th power. Or another way to think of it is how many times does x go into 3x to the 4th power? And it's 3x cubed. Now I personally write that on top of my x cubed component in the dividend. You don't have to. I don't care. All right. So what is 3x cubed times x?
4.
Exactly. It should be exactly the same. That's the whole point.
And it's also fast, right?
It's always going to be subtracting for long division. What's 3x cubed times x, or times 1, excuse me? 3x cubed, a positive. So as Lexi said, it's always subtraction for long division. This will be 0, but 0x cubed minus 3x cubed is negative 3x cubed. Very good. So many students will write positive 3x cubed there. Yes, I'll have calculators for you tomorrow. Bring down the other stuff. Yeah. Go for it.
Why is there a 3 x to the fourth power and the other one is 3x and the third power?
Like here?
Yeah.
So I take the red, this can be my answer, my quotient, and I multiply it by the divisor. So anything I write up here needs to multiply by the divisor, and that's what I write here.
Oh, because that's an x, and then you're multiplying by x, you add another x, right?
Yes, whenever you multiply your variables, you add the exponents. So,
yeah, that one happens to the second part, 3x to the third power.
so 3x cubed times 1 is 3x cubed.
Oh, okay.
All right, so we're going to repeat the process, but now I care about this new part of the dividend. How many times does x go into negative 3x cubed?
Negative 3.
X squared, right? The idea is we have one less here, so we need to do one less of that. Negative 3x squared. Okay, let's multiply. Negative 3x squared times x should give me negative 3x cubed. That's the whole point. Negative 3x squared times 1 is negative 3x squared. Subtract. Negative times a positive is a negative.
Oh, he's talking about negative minus a negative.
Oh, well, that actually, no. This negative has nothing to do with it going positive. Subtracting a negative does become addition. Okay, so negative 4x squared plus 3x squared is actually negative x squared. Again, if you need the calculator for that, go for it. Totally fine. Cool kids don't do that, Pablo. It's okay. I didn't say he wasn't. I said the cool kids don't do that. Pablo can decide what he wants to be. There you go. All right. Repeat the process. How many times does x go into negative x squared? I heard somebody already say it. Minus x. All right, so we multiply negative x times each of those. We get negative x squared minus x. All right, what is 4x minus negative x? And Pablo, this is the same thing that just happened. Actually, no, subtracting a negative x is going to be adding x. I know it's weird. So it's actually going to be 5x. I mean, hopefully not. Because if you think subtraction, you think, okay, 4 is going to get lower. But subtracting a negative means you got to go the other direction, so it's going to get higher. Always think back to when you were in when you were probably in, maybe you were in 3rd or 4th grade, maybe you were in middle school, and your teacher rolled out the big number line mat. I used to do it with my students in 4th grade. And have them walk up and down the number line. No, you guys never did that? Oh man, you missed out. Wow. You did the number line thing? Right? I think it's very helpful to visualize it. Or even when you were in middle school or early high school and your teacher had a number line on the room.
Oh, yeah.
I mean, I had a number line when you were in my class, Diana. I had a number line when you were in my class, Diana.
Yeah, where was it? I never.
It was actually above right next to where you worked.
Right here.
Oh, I think it was on this side.
Even you were facing you. If we're facing you.
Oh, okay. Diana, you worked right back there, and it was right there.
Boy, was there.
You were in my class now. Okay. How many times does x go into 5x?
5 times.
5 times, so plus 5. So that's going to be 5x plus 5. And we subtract, you get your remainder of 3. Very good. All right, now, just to make you feel better, right, I am going to look at your work. So if you make a mistake on the subtraction, it's okay. Right, I'm going to find out where you messed up. All right, but if you stop here, you're not done. Well, you can rewrite everything. I mean, I think I've done a pretty good job of being organized up here. So I would allow you just to write plus 3 over x plus 1. I guess I should have written it in red. I'm sorry. Okay.
Number 9.
I think I heard 8 before I heard number 9, but it doesn't matter because 8 and 9 are the same problem basically. Let me just pause here. Are there any questions on long division? So what's something that could trip you up tomorrow on long division? The place, well, it's always subtraction. The placeholder, if I happen to do a problem tomorrow, wink, wink, where I have something that's missing, make sure you have a placeholder. Pablo? Yeah, I think ox. But it might not just be 0x though, right? Because ours happen to be 0x cubed. But I want you to think ox, so like, hey, I need to remember the placeholder.
So then in long division, you have to subtract 1 to get an answer.
Yeah, basically that you'll notice I'm subtracting every time.
Spelling for long division.
That's in long division, because in synthetic, we're about to do synthetic, and synthetic is where you use addition. I think synthetic goes quicker, right? That's the whole idea, synthetic, fake, quicker. Can I erase this?
Yeah.
Okay, let me just look at 8 and 9 and decide which one I want to do. I'm not going to do 9, I'm going to do 8, but here I want to look at 9. If you look at 9, if you look at 9, you'll notice you'll need a placeholder.
Yeah.
Right? So when you write your coefficients, it's going to be 1, 0, 4, and then 10.
Wait. Oh, we did lots.
Yeah. Say it again. I would love to get 0 because I'm going to need that when we do I think the next problem on the next page. But when I'm just doing synthetic division, Caesar, I don't need to get 0.
Oh, this is.
Sure, I'll set up 9, but I'm not doing 9. So you put -1 in the corner.
Oh.
Then you have 1, 0, 4, and 10. You always think opposite. I'm going to do 8, and then we can answer questions on 9. How about that, Pablo? All right, Pablo, tell me what numbers I should put here for number 8. What numbers should I put here for number 8?
1, 2, 5.
Careful.
-2.
Thank you.
5, -1.
Very good. That's a good mistake, Pablo. I'm glad you made that today and not tomorrow. Make sure you're putting the symbols, the signs.
And it's always plus the synthetic, right?
Synthetic division is always addition, so I'm thinking addition here. All right, so we're going to bring down the first number, which is the 1. Bringing down the 1, that number should multiply by my number in the corner, which gives you -3. You write it underneath the next number. Always use addition. -5. Positive 15, I agree. Which gives you 20. Then -60. And here's where I made a mistake on the key. I apologize. It's -61 as the remainder. Now, if you stop here, will you get full credit? No, you must put the actual answer. So we started with x cubed. So this is going to be 1x squared minus 5x plus 20 minus 61 over x plus 3.
So we don't put the negative on negative 61, we just put
It doesn't matter. This is how I write it. Some students write addition here, Dino, and then put the negative with the 61. Same thing. If you put plus but don't put the negative, it's wrong. I mean, it's not. I'm not going to just take a little bit off. Yeah.
So, you take one of the answers from the whole synthetic division.
Say it one more time. You take one.
One of the answers from the
Oh yeah, you take one away. So we started with x cubed. This will be x squared. So this one's the same idea. Started with x cubed. So this will start. The answer should be x squared.
maybe number 10.
Sure. Are there any questions about synthetic versus long division? You will have to do both tomorrow. Okay, I heard number 10. Oh, wait. Let me know when you're done. No, you're good. Write it.
Oh, no, I didn't.
Oh, I meant number 9. You can keep writing.
Oh.
I'm going to go Pablo and Bashir.
Don't you have to get 0?
So right now in this question, I'm asking you to practice a skill of synthetic division. I think number 10, I don't know what number 10 is, yes. Number 10 is where I'm going to do synthetic division, where I'm hoping to get 0, because then that means it's one of my answers, my roots. Well, we're going to do that, the rational root theorem. That's going to tell us which ones we should try in the corner. All right? That's where you're hoping to get 0. You're hoping to get 0 at the end. Where it's negative 61, you're hoping that to be 0. That's for synthetic division. But, for this, I don't care if it's 0. Remember, this is just practicing a skill. It's kind of like if you were to imagine, you're doing a shooting drill in practice for basketball. Right? You're shooting a bunch of three-pointers. I don't really care if they go in. Yes, I want them to go in, but I don't care as much. In the game, when you shoot, I want you to make it. I'm looking for 0. And that was a really good analogy. No one really gave me any credit for that. Yes, the test will be separate like that too. Yeah, you got it. Do you want 10 or 11 looks harder.
11 is harder.
Ooh, 11 is harder.
Yeah, why is there like all the 1/2 and 3/4?
Okay.
Why?
I'm trying to think what I should do. Okay, here's what I'm going to do. I'm going to do the problem, and then if you're not writing, if you're not with us, you're going to get behind, because I'm going to write. When I run out of room, I'm going to erase it and start again. Everyone understand? So you have enough. You have like the whole page. I don't when I work in this way. So I want to make sure you understand what I'm going to do. So if you're not caught up with us, I'm not going to wait. Oh yeah. I mean, this is the goal of doing all this is to be able to find it yourself, right? It'd be like saying I'm going to get ready to play a football game, and then you decide that all you're going to do is just do the punting and the kicking of field goals. That's only one component of football, right? This is the whole dang game. This is it. All right, I can do other analogies if you like. EA Sport. Electronic Arts Sports. All right. Plus or minus. This is 12, so what are my factors of 12? 1, 2, 3, 4, 6, 12. Now, Lexi asked, sorry?
Would you take off points in that if I just did plus or minus and then just put 1, 2, 3? That's what I do. 6.
Also, I have a question. It always has to be the last number.
Yes, always the constant. Now, you asked, why are there fractions? Well, look at the first number. Is it 1? Bless you. Is it a 1 here? No. So I need to take all these numbers and divide them by factors of 2. Well, the factors of 2 are 1 and 2. So it's all these numbers and these numbers divided by 2. So what's 1 divided by 2? 1/2. What's 2 divided by 2? It's already there. I don't need to write it again. It's already there. I'm taking, that's all I'm doing, the factors of 12 and dividing by the factors of 2.
Why?
That's the rational root theorem.
Oh, so if there's
A rational root, one of these numbers.
in there,
Yes?
you have to take the root down to.
No, if there's a number that's here that's not 1, then you need to divide by the other factor. Right? If this had been 4, then I'm dividing all these numbers by 1, 2, and 4.
What consists of the rational root theorem?
What I just said. The factors of 12
No, but like about 2.
and divided by the factors of the leading coefficient.
So we have to take.
Basically, all this is telling us is giving us a roadmap for what numbers to try. As opposed to trying any number you want, it's saying, hey, try these numbers. It's trying to help you. Instead of trying, because if you tried 5, if you try 5, I know it's not going to work because it's not here. You don't know that, though. Yeah.
So from the last number, you want factors of it?
Guys, it's not going to be a fraction. You've done these in Algebra 2, you've done these in Pre-Cal, you're doing them again. It's not going to be a fraction. All right, I'm writing the fractions because those are the other answers, but ultimately it's not going to be a fraction. All right, it's going to be a whole number.
When you divide all of the factors from 12, it's 5 and 2.
That's exactly right, and you get those numbers. The reason it's not more fractions is because 4 divided by 2 is 2, 6 divided by 2 is 3, 12 divided by 2 is 6. The only ones that I needed to add were 1 divided by 2 and 3 divided by 2, because they're not up there yet.
Oh, no, I was going to say that you probably won't even have to check that.
You won't, I'm telling you,
Yeah.
you won't have to check fractions, guys.
But if I don't write it like this.
No. Oh my goodness.
It just kind of hates it.
Okay, then put all the fractions. 1, 2, who's got 10? 1, 2, 4, 8. Oh, 10. Oh, I'm sorry. We didn't do 10. You want to know the numbers. Yeah, it's plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. And then there's no other fractions because there's 1 half. But 2, 4, and 8 all divide by 2 give you numbers you already have. So the only fraction for 10 is plus or minus 1 half. But again,
What?
you won't need to use the fraction. You guys don't believe me. That's all right. Here we go. You know I'm going to start with 1. All right, my numbers are 2, negative 17, 46, negative 43, and 12. Am I missing any? Do I need any placeholders? No. Let's hope 1 works. Please, God, let it work. Bring down the 2. 2 times 1? 2. That's negative 15. That's negative 15. That's 31. That's 31. Oh my gosh, guys. It worked. The first one. Woo!
Okay, but that's not how it's presented. Knowing you.
Whoa.
Oh man. Hashtag shade. Now, you're right, Diana. Tomorrow might not be the very first one.
Is it just one of these?
There's just one of these.
Oh,
Because it's long, it's hard.
Oh, yeah.
We will mess up. I would say, I think it's 25% of your grade is on this problem.
Oh, no. I love it.
I mean, that's the whole point of this, right? Okay, so what do I do when I get one? Because that's awesome, but you got to know what to do.
Now you gotta rewrite it.
This one, I want to write as a factor. So you want to think opposite. Very good, Liz. X minus 1. This would be an opportunity for you to learn here, because this is going to be, I would say, the most points come off of this problem tomorrow. Not trying to scare you, but I am. So, x to the 4th power. So this is going to be 2x to the 3rd power. Minus plus 31x minus 12. Now, if you're lucky, tomorrow, when you get to this point, you're hoping that you can factor by grouping, which we did last week, where you take something out of these two, and you take something out of these two, and it leaves you with a common factor. Sadly, just looking at this, if I take out x squared, I'm going to be left with 2x minus 15, and I cannot take anything out of these except for number 1. And that's not going to leave me 2x minus 15. So you can't factor by group. So what do you do? Heck, that's definitely not it. You got to do it again. So do you see how we use these numbers? We only use which number? So what's the next number I'm going to use? Negative 1. Now be careful here. This is what I tell students, is we're taking this and we're whittling it down. We've already gone from x to the 4th to x to the 3rd power. So now, you see when I wrote these numbers? I'm not going to use those numbers. I'm going to use 2, negative 15, 31, negative 12. With the new numbers. Exactly, Jimena. Nice. Could happen to you. I still remember when I was 16 doing these problems, my teacher gave me one that was x to the 6th power. That was like 2 pages of work. It was so much fun. I enjoyed it. Yeah, it was a lot of fun. I told my teacher the next day, I was like, I want more problems like that. That was so much fun. Whatever you get in the corner. So see how this is my root? So when I get 0, I'm like, yay, good job, guy in the corner. And then that guy in the corner becomes my factor. But always think opposite, Jalissa. Always think opposite. Okay, let's see if -1 works. 2 times -1, -2, -17 times -1 is 17. That's going to be 48, I think. And -48, ooh, that's -60. No dice. So -1 didn't work. So now I'm going to what number? Positive 2. I have to go positives first. Positive 2. I'm going to move over here. With the same numbers. Yes, Pablo. Basically, once I find a root, I should not be using those original coefficients anymore. Bashir, I think you said something? Okay, I'm sorry. 2 times 2 is 4. That's -11. I'm sorry? Using these numbers? Yeah, I'm using these numbers only. I'm using these numbers. No, you're good, Jimena. I'm going to repeat this process until I get a 0. You're saying -17. I'm not using these anymore, Jimena. Jimena, I'm not using these anymore once I get one. I'm using the new ones.
She's
No?
confused because, okay, so you know how the other one got 0, but this one you didn't get 0?
I didn't get 0.
You didn't get 0. You have to use the same.
Okay, Jimena, if I had not gotten 0 for the first one, I would have used these again for -1. Is that what you're saying? Yeah, okay. No.
No, because you see how you got the -1, 2, -17, 48, -60?
Yeah.
Just asking why aren't we using
Because if I don't get 0, then this is, you're going to throw it away. If I don't get 0 in the corner, do not care. It's like I didn't even do it. I mean, I did, but I don't need it. No, doesn't understand? Yes, okay. All right. 31 and -22 is 9. Shucks. It's 6. So, Jimena, I didn't get 0, so I don't care. Right? I mean, I did the work, but it's as if I didn't do it. So you know what I'm going to do? I'm just going to erase all that and just keep going until I get it. Sound good? So you should be rewriting this again. You should not be erasing. And I'm going to put a new number there. Yeah. I think you're going to find, I think you're going to find out. We're going to get it. It's going to happen this year. -2 is next. Please, God. 2 times -2. -4, -19. That's 36. Uh-oh. No, that's 38, Douglas. Doesn't matter, though, because it ain't going to be that number. That's, oh my gosh, that's 38. Oh my gosh, that's -150. That didn't work.
We're going to continue again?
Yes, we're going to the next one, which is +3, I believe. Yes, it's +3, Caesar?
Yeah.
No?
No. It is.
2 times 3 is 6. That's -9. That's -27. But you wrote 4, Douglas. -27. That's 4. Oh my gosh! Woo! We got it. Only on the 4th try. Not bad. Okay, so I'm going to wait. I'm going to count to 30, and I'm going to erase all of this. Mm-hmm. I mean, you don't think I can count to 30? Ooh, in Spanish?
Yeah.
Ooh, that'd be hard. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11. 11, is it? 11, 12. My teacher's gonna die! No, I'm asking myself! 11, 12, 13, 14, 15.
Leave him alone.
It's already been 30 seconds. Okay. Let him fail. All right, that'll be my motto. That'll be my motto tomorrow.
You know, like her fashion show, like it's straight
All right, we're continuing. We already, again, you should be continuing down the page. We already had x minus 1. Yes, that one was already there. We just found positive 3 was a root, so x minus 3. Okay, 20-second or full.
You add the x minus 1 and 1.
I didn't add. I mean, basically, I'm trying to take, hold on. I'm trying to take this entire polynomial and factor it. So far, I've found 2 factors, because those are my 2 roots. Now, the numbers that were left was, I think it was a 2x. Bashir, this is your question. Right now, it's x squared, right, because I started it cubed. Yes, so now it's x squared minus 9x plus 4. Now, I want to make sure we all understand. I'm going to go over it. I want to make sure you all understand that this original polynomial is still here. It's the same thing, but it looks different because we're factoring it. But it's still x times x squared is x to the 4th power. So it's still the same. Okay, now the factoring. When it's a number that's not 1 in front, and this could happen tomorrow, what I tell students to use is a different method that I haven't taught you before. I'm going to teach you now, see if you like it. Some of you, have you had Mr. Goldsberry yet?
No.
No one's had Mr. Goldsberry? He calls it the bomb method, because this is more like when I was in school. It's the bomb. From like the 90s, early 2000s. Like if it was cool, be like, oh, that's the bomb. You guys don't know what that means, because we actually would go when like the internet came out, because I was alive before internet, that it used to be you were the debomb.com.
Well, we still say that, like, oh, that's wrong.
See, there you go. You still say it. There you go. All right. So what I want you to do is write 2x squared. Right? 2x squared. Dino, I'll say it with you. Don't worry. 2x squared. Now, do you guys see the 2 and the 4? The first number and the last number. Multiply those. You get 8. Oh, yes, it's a positive 8. 2 times 4 is 8. Does everyone see that? All right. So when I'm thinking about what my numbers I'm going to use, it needs to multiply to give me 8. So let me write it like this. Multiply to 8. What's the number in the middle? Negative 9. So they have to add to negative 9. So ask yourself, what 2 numbers are going to multiply to give you 8? 1 and 8 do, but they don't add to negative 9. Very good. Negative 1 and negative 8. All right, now watch this, because these are the 2 numbers I'm going to use right now. Here we go. Here's the bomb method. You ready for this? So this negative 9x, I'm going to write plus negative 1 plus negative 8 times x. Now let's see if your brain can see what I just did. I just took this negative 9 and broke it up into negative 1 plus negative 8. Do you agree that negative 1 plus negative 8 is negative 9? Then I haven't changed the problem. Even though it looks different, I haven't changed it. And then bring down plus 4. Now let's distribute that x. What is negative 1 times x?
Negative 1.
Very good. What is negative 8 times x?
Negative 8x.
Great. I know. Now I want you to take your pen or pencil, and we're going to make this into a factor by grouping problem.
How do you know which one?
What do you mean? Yes, always 2 and 2. Yes. This right here? This is not x plus 4. It's negative 1 plus negative 8, which is negative 9x, and then plus 4. I'm trying, Bashir, to show you that this up here and this right here should be the same thing. I distributed this x. I multiplied it onto each number. Okay? So what do... Sorry, Paulo?
Why do we have to multiply 4 times 2 and find 8?
So it's always, when you do this bomb method, this is A and this is C. So you multiply A and C, and they have to add up to give you B, which is the middle number.
Okay.
That should hopefully that should sound familiar.
How did you get to do it in the second part? How did you?
I took the two numbers and I put them in parentheses because that becomes -9. It's the same thing. Yeah, it's always addition. All right, so what do 2x squared and -x have in common? X. What's left? 2x minus 1. What about -8x plus 4? Negative. I think I'm more -2. -4. Right? If you take out -4 from each of these, what's -8x divided by -4? 2x. And oh my goodness, what's 4 divided by -4? Guys, they have the same factor in common, right? That's the whole point. So you have x minus 4, it's the bomb, and we're done with the bomb. Well, Gilberto, I had to teach it, right? When you do this 50 times, it'll take you 90 seconds. Yeah.
Well, would you consider 2x minus 1? It's going to be 2. It's going to be plus and minus. So
No, the plus or minus is when you have like squared.
okay, but you have to have 4.
Yes, well, I didn't bring these down yet.
Oh.
And now, Diana,
Okay.
we have 4. It's Thursday. We have 4. Yes, you want to do another bomb method? You got it.
Can we do 10?
Well, I'm not done. Should we finish the problem?
Yeah.
So it's x equals 1, x equals 3, x equals 4. Be careful on this one.
Oh, you got
Very good. What'd you say, Lily?
yeah, you got the
And guys, what's really cool, you didn't even know this, but if you were to look up at the very top of your paper when we did the plus or minus all those numbers, all of these numbers are there. Thought that was interesting. All good, Viviana?
So we're done.
I'm done. Now, I think somebody said they wanted help on factoring with the bomb method. Should we do another one of those?
Yes.
Okay, so what I'm going to do is I'm going to open the key to look at how the other one is factoring, number 10, and I think there's another bomb method there.
Yeah, there is.
Perfect. I posted it, right? I think it's on my desktop. Anything.
1, 2, 3.
I don't think you need to use the bomb method because there's no 2x or 3. Like if the number in front of x squared is not above 1, then you don't need to use the bomb method. I'll show you what I mean. I'll show you what I mean.
What did you say?
Yes, if the leading coefficient of your quadratic, so a, if a is not 1, you should use the bomb method. If a is like 2 or 3 or 4 or 7 or whatever, right? But if a is 1, you don't need that. You should be able to, with all the factoring you've done in the last 3 years, you should be good. Just waiting for the PDF to load. I don't know why with these surfaces, Adobe PDF always takes forever. See, like I clicked it. You saw how earlier I clicked that, right? No, you weren't. You were watching. I'm just kidding. So what I would say is, if you look at number 2, you're asking about this for 1, 2, and 3. Do you see how this has a 1 in front? Yes. Do you see how there's a 1 there? If there's a 1 there, I don't use the bomb method. I ask myself, what numbers multiply to give me 4, but also add to give me 4? And it's 2 and 2. So that's why I wrote x plus 2 squared. Okay. So number 10, and then let's do the bomb method. Okay, so write this down. 2x squared minus 7x minus 4. 2x squared on number 10. I mean, somewhere in number 10.
2x squared.
Minus 7x minus 4. Is that what I said? 2x squared. No. I'm just doing the bomb method here. Yes, everyone see that this is like later on in the problem?
Yeah.
Like you've already found a root?
Yeah.
Check the key. All right, so bomb method. Let's bomb method this. What's the first number and the last number?
2 and negative 4.
Great, multiply them.
Negative 8.
So they have to multiply. Go away. Nope. Thanks. So multiply to give you negative 8. What do they have to add to give you? The middle number, b, which is negative 7. So ask yourself, what two numbers make that true?
1 and 8.
So it's 1 and 8, but 1 and 8 does not multiply to give you negative 8.
8 and 1.
So 8 and negative 1. So 8 and negative 1 will make one of those true, but not the other one. Because if I add these, Dino, I get positive 7. And I want negative 7. So actually the two numbers are negative 8 and positive 1. Okay? So here's how I write it. 2x squared is the same. I always write an addition symbol, no matter what. Then I open parentheses to put my two numbers. Negative 8 plus 1.
If it would have been a negative number, would you do
Yep, negative 8 plus. You could write negative 8 minus the number. I always write addition. If it would have been negative, I would have written negative 8 plus negative 1, just like we did in the last one. Put the x, and then bring down the minus 4. So what I'm hoping your brain sees is that I still have negative 7 in front of x. Right? Negative 8 plus 1 is negative 7. I haven't changed the problem. So now I'm going to distribute what is negative 8 times x.
Negative 8x.
Very good. And then what's 1 times x plus x minus 4. And then it becomes, should write it here, factor by grouping. All right, and Dino, as you said earlier, is always grouping the first two and the last two. Pablo.
Okay, so you multiply the one with the 1 in front of the parentheses.
No, I'm like here, because this number is 1, 1 times x is x. If this had been 4, it'd be 4 times x is 4x.
And then you have negative 8.
Because negative 8 times x is negative 8x. If it helps you, Pablo, you could write this x, to see this x, you could write it in front.
Yeah.
If that helps you, that's fine, I don't care. The reason I wrote it there, Pablo, is so you can see it's still negative 7x. Negative 7x. That's why I wrote it like that.
And then after this,
We group them. We should group them,
We factor them again.
and you're factoring within the groups. So what do these two terms have in common?
2x.
2x.
So then you do 2x.
What's left when you factor out 2x?
4.
X minus 4 is right. What do these two have in common?
They're both
The answer is nothing. But what's the sign in front of x?
1.
So it's an addition sign. So you factor out positive 1, and what's left? The same thing. And guys, when you do this, you should always get the same factor in the parentheses. So this is going to become 2x plus 1 times x minus 4. Right here, these should always be the same. But your x minus 4s, it might not be x minus 4, right? But they should be the same. Now, do you see how I got the 2x plus 1? I took the 2x and this positive 1 and made a factor? Okay, that's called factor by grouping. Yeah, I mean, that's to finish the problem. So this is factored. No, so they share it, so you just bring down 1, since they share it.
So
Every time you have a quadratic trinomial that has a number in front of x squared that is not 1, I would recommend the bomb method.
If it's 1, don't use it.
If this is 1, no, you shouldn't use it. I'll give you an example. Okay. Ready? Right, you see how this is 1? Not going to use the bomb method. Ask yourself, what two numbers multiply to 15 and add to 8? 5 and 3. So we have x plus 5, x plus 3. We're done. That's called factoring.
Wait, so the last number is always going to be 1.
Yes, but you'll notice it's much easier when it's 1 because I didn't even need to care about this, right? It is 15 times 1, but if that number's 1, it's not going to change it, so I don't care about it.
Oh, so
What?
you multiply whatever it is.
Yeah, that's why we did 2 times negative 4 and got negative 8. Diana,
why do you have that 1?
I just made it up, man.
Like, where did you get that 1 from?
What 1 from?
Why? So 1 in front of x minus 4.
Oh, so when I do grouping, if they don't have anything in common, I have to take out a 1. And Diana, I always look at the sign in front of this term. Look up, look up, look up. I look at the sign, that tells me what sign should be in front of my number. Always. All right, I'm going to stop here. I know we didn't get through everything. All right. I'm going to do this with another class, so maybe they'll pick different numbers. I'll post both videos. You have my key. You can email me questions tonight if you have any concerns. All right, just let me know. You're going to have my test actually tomorrow because of the schedule. It's before lunch. All right, so it's the last period before lunch. Tomorrow we're going to go 5, 6, 7, 8, 1, and then you have lunch. All right? It's not going to be on there. It's just slant asymptote is just long division. Just divide, long division. Sure. Assembly is at 1 o'clock, 1 to 2. So you'll go lunch, another class, then communities, assembly, and then 2 more classes. It will be weird. You know what? I don't make the rules. Okay.